and welcome to a video on doing electron configurations using the periodic table method. In this method we will use the periodic table as a way to give us cues as to how to fill up those electrons from lowest energy to higher energies and give us the electronic configuration. This method will make more sense if you've done the arrow filling before this time. We have another video on that and I hope that you can find it or look into a textbook. Alright, so for this, the periodic table has different rows or periods, and they then reflect the shell number, and so I've written those along the left side of the periodic table here. Then we can also separate the periodic table into blocks, if you will. So this first two columns form the S block, the rightmost 6 columns form the P block, the transition elements hunkered down in the middle form the D block, and then the transition metals that are at the bottom of the periodic table, those form the F block. Now for the D block and the F block you need to take the row -1 and -2. Okay, I'll explain that more in just a moment. In short, it's a change to make it work. Okay, to make it fit what we know to be true. Alright, now we can choose an element and practice doing the electron configurations. We're going to assume that we're going to use each of these boxes on the periodic table, 1, 2, 3, etc., as being representing an electron, if you will. So we can start with something like sulfur. Sulfur is right here on the right side in the periodic table. So to do sulfur, I need 16 electrons. I get that from this number here on the periodic table. Okay? For 16 electrons, I need 16 boxes, and in particular the 16 boxes preceding sulfur. So I have 1 S2. Notice that's an exception. It's counted as S even though it goes across S and P. So 1 S2 for row 1, 2 S2, 2 P6, 3 S2, 3P, 1, 2, 3, 4. Isn't that so great? I love it. Okay, so then the periodic table method really shines when you want to write the shorthand notation. So the shorthand notation, you go up one row, all the way to the right, and look at the noble gas. That's neon. That's your core electrons. And those are 10, so I'm going to take those. That becomes shorthand neon. Cool, 10 electrons. Then you write what remains, 3s2, 3p4. Or sometimes all you need is the valence state. So you see sulfur. I see sulfur is here. So it has neon as its core, and its valence is 3s2, 3p6, or just count the boxes on the row. 1, 2, 3, 4, 5, 6. It has a valence equals 6. And that helps with Lewis dot structures because then I know to draw S with 6 dots just by looking at where it is on the periodic table. I can also then tie this in with the energy levels. I can have my S and my 3 P's, remember that? This is 3s and 3p. Again, I'm just writing the valence only, not the core. I have 3s2, 3p, 1, 2, 3, 4. And so I can get straight to that using the periodic table as well. Oh, it's so great. I love it. All right, let's do another example to make sure we know it. Let's make this one be interesting. You know, something with a little challenge. How about tellurium? Now, just by looking, I know that it's going to end in P1, 2, 3, 4. Agreed? S2, something D, and then P4. Great. Let's do it now. All right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, this is 3d, 10, 4, back to 4, p6, 5s2, 4d10, 5p4. Yay! Or just write krypton, and there you go.